Okay, now I'm going to show you three insanely important shapes. Okay. Now there are at least five insanely important shapes. But if you understand these three, it's a real good start for understanding the five. And then there's much more after that. But once you understand the most basic ones, it's not difficult to understand the rest in most cases. Okay. Now these are insanely important because they're graphs of functions. And the functions are the main functions that we study in pre-calculus and in calculus and in second year calculus and even beyond. They're the shapes that we use to model reality. Okay, whether it be a business financial reality, chemical reality, physical reality, an engineering reality, or just an everyday reality that we would do better if we know how to deal with. And that was a terrible sentence, but okay. Okay, so three insanely important shapes. I'm going to draw them for you. Now, each one is drawn inside a rectangle, a square. Okay, there's a red dot at the base along the lower edge of this square and along the lower edge of this square, in the middle of this square. This graph will go through this point, and this point. And it'll do so in something like the smoothest possible way. So don't know if I'm going to draw this very well or not, because it's hard to see around my hand. Yeah, it's a little too flat, maybe, and not as symmetric as it ought to be. But there it is. Okay. This is an attempt, my attempt to sketch a parabola. A little too flat. It should be symmetric about a line through this point that's in the middle of the lower edge. Okay, this vertical line in the middle of this edge. Okay, that's one graph. Here's another one. It starts a little way above the lower left-hand corner, and it goes to the upper right-hand corner. And there's actually a word for what it does. It increases exponentially. But I'm not sure I got a good exponential increase there. It's hard to draw these things really accurately, even though I've drawn them many, many times. And my eye kind of knows what it's looking for. Okay, so I'm not going to expect you to freehand draw a great curve. But if you draw this one and it's humped up this way, you did it wrong. Sorry. Okay. If it starts in the lower left-hand corner, and if it has the right shape, I'll say you're close, but it needs to start a little higher. All right, and eventually you're going to do it right, because eventually we're going to do it with numbers and it's going to make it easy to get a good accurate graph. Okay, now here is an aid in doing this graph. I don't really need a vertical or horizontal line through the middle here, because there's no symmetry in this one. This one has a certain type of symmetry. And there are other reasons for wanting to draw the vertical and horizontal line through the dot. Okay, so the curve starts up here a little bit to the right of this dotted line. It comes down here a little bit above this dotted line, and it kind of does this. Now, we can be more specific about how far and all that stuff, but just a little bit to the right, a little bit above is good enough to start with. Something like what I've drawn here. I could have drawn it more accurately, and we will draw it more accurately. Okay, this curve, similar, but it's down here. This would be the, if this is the X and Y axis, this would be the first quadrant, this would be the fourth quadrant, third quadrant, so can't count to four. Okay, so it's going to look something like this. And there's kind of a symmetry across the origin here. I take a point up here, and draw a line through the origin, I get the corresponding point down here. It's just as far from the red dot. And don't worry too much about that, I'm just pointing it out. But the symmetry is important. Okay, so this one I think is reasonably well drawn. This one's a little too flat. This one, I don't know yet. I'd have to test. All right, well, those, like I say, the three insanely important shapes. Now, red dot for each of these shapes comes at the origin of our XY system. So this is X and this is Y. And the red dot is here. Then my rectangle. Well, I'm going to say I have to draw this in this selection. That part. Probably have to be a little higher. It's a square. It's supposed to be a square. Not a great square. It's close enough. And the other thing about the square is its dimensions. Each of these squares has dimensions 4 by 4. So if I draw that square, point here, and I can come down too fast. That's a little lopsided. Hard to do this. Okay. If I was straight on it, I'd be blocking the board and it still probably wouldn't come out that great. So we'll just live with this. It's not as symmetric as it ought to be. Now, if this is a 4 by 4 square and this is the middle of the lower side, then you can immediately conclude what the x coordinate here and the x coordinate here. So the x is going to have to equal 2 here and negative 2 here. Whatever the x is here, it's got to equal this because this is halfway between this and this. Okay. And since it's got a width of 4, tells you go from negative 2 to 2. So you should be very clear on that. So the other thing is that up here on this line, y equals 4. So we know the coordinates at 3 points. We know this point is negative 2, 4. This point is 2, 4. And this point, the origin is 0, 0. And so there we have a pretty good graph of this insanely important shape. It's got a name. I'm not even going to tell you what the name is, but I want to see that you have the ability to draw these 3 shapes and then sketch a reasonable graph with an X and a Y axis and label some points on the graph. Okay. Well, let's go ahead and do that with this graph. Now I'm going to here. Very horizontal, but there we got it. Okay. Again, this is negative 2 and this is 2 because the red dot goes at the origin. And up here we have the line y equals 4. And then we have our point down here, our point on here. Now that curve isn't as curvy as this curve was. Really not a very good approximation to an exponential curve. But so be it. To learn to draw a better one, we do some numbers. All right, so there we have. Then this curve, if we situate it on the XY, okay. The only point I'm going to really label on this one is 0.24. This point's kind of close to negative 2, 0, but you don't know how close. I can't really label it. I know what the coordinates of this point are. It should have been just a little bit lower, but not going to tell you now. give you formulas. It's simple, very simple formulas. And do the arithmetic, you make a table and you can go out a nice accurate graph. Okay. The reason I'm not giving you the formula and having you do the table and so forth is, number one, you're probably going to be tempted to use a calculator, which I'm not going to permit. Calculations are so simple that there's absolutely no reason to use a calculator, except that some of them involve some facts about arithmetic you might be a little fuzzy on. We're going to take care of that before we start doing these tables and start actually plotting points. Okay, so this graph, the red dot is at the origin. And still a 4x4 rectangle. So below the origin, we've got to go 2 units below the origin or 2 units above the origin to get the lower and upper sides of the rectangle. Like I said, okay, I'm going to put y equals 2 here. And I'm going to put y equals -2 here. Now 2 is a little too high, like -2 is a little bit too low. So when you do it, try to be better than that. Okay. And then we got to go 2 units to the left or 2 units to the right of the red dot. That'll take us over to x equals -2. Now if I use this size, okay. So x equals -2 in this line, x equals 2 in this line, and now we can sketch our 4x4 rectangle. Not shortly, I'm going to tell you what the coordinates some of these points are, and I'm not going to tell you now. I'm just going to say start a little bit below the x-axis, like we did here. A little bit to the left of the y-axis, very simple. Here and here. And then we're going to nice smooth curve. You might be tempted to make this the arc of a circle, but that would quite be fun. Circle centered here. An arc of a circle would be pretty close, but it's not going to be exactly right. Okay. So there we have the 3 graphs in the coordinate plane. And now you could take your graph and you could estimate the value of y for given x. You could estimate the value of x for given y. You do all those estimates with these graphs, and I might well ask you on a quiz to construct these 3 graphs, or maybe 2 of them, or maybe just 1 of them. And the one you construct might not be the one somebody else near you is constructing, so do it yourself. Okay. You want to construct all 3 graphs or any subset of the graphs, and then I ask you, okay, if x equals 1, what's the value of the curve here? And I would say if x equals 1, that would be here. We go up to here and over to here. It looks like a little more than 2, maybe about 2.4. I don't know. That's not what it should be, but that's what the graph tells you. Okay. If x equals 1 here, come up here, and it looks like y is pretty close to 1. If x equals -1 here, y should be pretty close to -0.9 or something like that. If y is equal to one and a half. Okay, here's 1, here's 2, here's 1.5. Go across here and down to here. It looks to me like x would be about 1/2. Okay. That's what it looks like. That's not what it really is. When I define these functions, the formula will tell you something a little different. But if you draw these things pretty carefully, just slot them down, make them look kind of like the way I made them look. You're going to be surprisingly close, I think, to the actual values of a function. Not insanely close, surprisingly close. Okay, again, these are insanely important shapes. And I'll even give you some names. This is your basic parabola, it's your basic quadratic function. This is exponential, and this curve is better than this one. And this is reciprocal, or inverse proportion. Those three things make up the majority of, or are the foundations for the majority of the functions that you use to model reality, at least as far as you're going to learn it in 2 years, even if you're going into engineering or physics. Okay. Now there are two more of the five most basic, and once you understand these three, it's going to be easy to understand those. We're just going to confine ourselves to these three. These are insanely important. Keep that in mind.